As you understand, in geography, in the June examinations, you won't be in a position to cover or to write a full scope examination of 2 papers. You understand you're supposed to have a full paper for paper 1 and a full paper for paper 2. That will only realize during the prelim exams. For the sake of the June examinations, you will cover the 3 main topics, the 3 core topics of theory, which is your paper is going to be encompassing the first 3 main theory topics of number 1, the topic of climate and weather, and that will be attributed 40 marks. Then we'll also cover geomorphology. It will also be having 40 marks, and the study of settlements with 40 marks. Then, as usual, we are supposed to also do your geographical skills and techniques, which is your map work, with 30 marks. So if you check, we are saying 40 marks per each question for the theory questions times 3, which is 120, plus 30 for geographical skills and techniques. That gives us a total of 150. So that's the setup of your June exam paper. It is going to be having 150 marks and to be written in 3 hours. So it's more or less, it's the same mark total as a full scope paper, but the only difference here is the paper 2 is not covered fully in the June examination. You are only covering one question of the paper 2 section, which is settlements. Right. So we're going to use this sample paper to try and figure out how best we can attempt to respond to the given questions, and also we try to elaborate on how best we can find out ways of answering our questions effectively. Right. Without wasting much time, we need to go to our first question. Our first question is a question on climate and weather, which is ultimately a multiple choice question. Right, the first question is saying the sketch shows the dash stage of a mid-latitude cyclone. Right, that is a mid-latitude cyclone. We are seeing in this illustration, our mid-latitude cyclone is having the cold front, which is indicated here. This is our cold front, the weather system. And our warm front is also indicated here. So we are saying this is our warm front of the system. This is our cold front of the system. And in between here, we have our warm sector, as usual. Our warm sector, that is where we find our warm air. And because of the movement of the cold front towards the warm front, there is an upliftment of the warm air in the warm sector that gives rise to the formation of these towering cumulonimbus clouds that produce heavy rainfall just ahead of the cold front. So which stage of development is this? Is it an initial stage, mature, occluded, or degenerative? Automatically, the correct response there is the mature stage. During the initial formative stage, the 2 air masses will be moving parallel to each other along the stationary polar front. And when the system matures, that is when we start realizing the upliftment of warm, moist air, forming cumulonimbus clouds and forming heavy rainfall. When it reaches occlusion, I understand during occlusion, it means that point in time, the warm sector would have narrowed and the cold front would have caught up with the warm front, which is not our situation here. And during the degenerative, we're saying the system is dying out. So the correct response is the mature stage. It's reached maturity. Then number 2, it says dash clouds form along the cold front. I think it's clear. The type of clouds that form along the cold front are these types of clouds here, the cumulonimbus clouds. So it's our cumulonimbus clouds that form as illustrated on the info and then the sketch there. You can actually see that there is formation of the cumulonimbus clouds just ahead of the cold front. Right. The cold front has a dash pressure gradient and moves dash than the warm front. The cold front has a what kind of pressure gradient does the cold front have? We are looking at the pressure here and the pressure ahead here. What kind of gradient is that one there between those two? Along the cold front, we understand the gradient is steep. Is steep in the sense that there is excessively high pressure behind and lower pressure ahead. That is why it tends to move faster. Because of that difference in pressure, there is a steeper gradient and that tends to drive the cold front faster in the direction of the warm front. And it moves, automatically it moves faster than the warm front. So if you are taking those two items, we are taking the first item and we are also taking the fourth items. There's a steeper gradient and then it moves faster than at the warm front. So a combination of those two, we find it at option C. Right. Then number 4 is saying the warm sector causes air pressure 2 and humidity 2. Right. The warm sector, how does it affect air pressure? In the warm sector, we are saying the air pressure is decreasing. There is low pressure here. The pressure is low. So we are saying the pressure to decrease in the warm sector and the humidity also to decrease. How does humidity decrease? Humidity decreases in the sense that this is warm sector with warm and moist air. But however, the coming of the cold front, it is going to cause upliftment of the air. And as the air uplifts, it is going to reach dew point, it is going to reach condensation. And as it condenses, the moisture is going to get lost. As we receive precipitation, it means we are losing the humidity in the air. So as the air is forced to rise, because it's a low pressure, the air is forced to rise by the coming of the cold front. Ultimately, the air is going to rise, it's going to condense and create precipitation. So the humidity is going to be lost with the formation of clouds and ultimately the formation of precipitation. Right. So it's A. Then number 5, 115. It says the sketch below shows a local climate of an urban area. Before that, number 115. The sketch below shows an occlusion that formed because. This shows an occlusion. If we see here, this part is a cold front. And this part here is a warm front. So here we experience a situation of an occlusion where we have the cold front which has caught up with the warm front. It's an occlusion on that part of that system. So what situation best describes the occlusion is warm air was uplifted along the cold front. Warm air being uplifted, if you are to draw a cross section, we will see that there is a cold front and the warm front will not reach the ground surface. This is our ground and this is our direction. So our warm front will be there, our cold front will be there. So it automatically means now that the warm sector, warm air is now rising above the cold air, with the cold air touching the ground, implying that it's a cold front occlusion. So this happens, this is the situation of an occlusion from this part to this part here. This is the same part as this one to this one where we have an occlusion. We are saying this area in this part here, warm air has been completely displaced from the ground surface. Right, so that was question number 1.15. Let's go to question number 1.2. It says the sketch below shows the local climate of an urban area. Select the correct option between brackets so that each statement reads correctly. Right, I'll explain this before we answer the questions. This is typical of an urban profile situation. When we're looking at an urban profile, we are saying we are having a side view of an urban area. A side view, if you see, this is our built-up main urban area, which might be our central business district, and we are moving out of the CBD into other zones outside. And the further we move away, we go to the rural communities. So if we look at this, it actually gives us an impression of the side view of some urban areas. We start from the high-rise buildings at the center of the built-up area, which is the urban, which is most dominantly our central business district. We move out to other land use zones outside of the urban CBD until we reach to the rural areas. So this one here is also giving us the situation of the temperature as we are comparing the profile from the outskirts into the center of the CBD. If you look here, we see our temperature reading is here in the rural area. It's somewhere here again in the rural area. But as we are approaching the urban area, you see our temperature is beginning to increase. As we get to the high-rise buildings, our temperatures, they reach the highest point there. And gradually, as we move away from the urban built-up CBD, the temperatures, they start to decline, and they also decline going to the other side of the rural area. So actually, the trend of the temperature, if you are seeing, is as we move from the rural area to the urban area, there is a general increase in the average temperatures as shown by the graph there, which shows the temperatures. Then, if you also look at this illustration here, marked by this, yes, this one marked by this boundary, this is what we call the shape of the pollution dome. The pollution dome in the urban area. Right, what we call a pollution dome, we are actually looking at the concentration of pollutants over an urban area. How concentrated are pollutants over an urban area? We understand there are so many pollutants which are emitted in urban areas due to several activities that take place. We might have dust particles, we have smoke particles from vehicles. We also have some smoke particles from industrial activities. So all those ones, they are pollutants, and they tend to accumulate over the built-up or the urban settlements. And for that reason, the pollution dome, it takes 2 dimensions. When we're looking at pollution domes, we look at the shape of the pollution dome during the day, and we also look at the shape of the same pollution dome at night. They portray 2 different shapes. So the shape which is being shown here, this shape of a pollution dome, these are our buildings. This is a day situation of a pollution dome. If you see a pollution dome with this shape here, it shows that this is a day situation, and I'll explain. And then if you see a shape of a pollution dome which is like this, our buildings are there. This is a night pollution dome. Right. What makes the difference here is during the day, remember there is insolation, and we have artificial surfaces in the urban area. like for example, tarmacs, paved surfaces, dark surfaces of buildings, or reflective surfaces of buildings. All those they tend to contribute towards higher temperatures in the urban area. And for that reason, we tend to find that the temperatures in the urban areas, they will be higher, like what is implied by that illustration there. As a result, we will have a situation whereby in the urban area, there will be low pressure because of high temperatures during the day. The insolation is going to be absorbed and is going to contribute towards a general rise in the average temperatures in the urban area, whilst compared to the surrounding rural areas. Here, we don't have much of this artificial surfaces here. We have natural surfaces. We have vegetation like what you are seeing there. We have water bodies. We have natural surfaces. All those ones, they are reflective and they contribute towards cooler conditions or cooler temperatures. So as a result, we tend to find that the pressure in the urban, in the rural area, will be typically higher. Will be typically having higher pressure in the rural areas. So as a result, you will tend to see that there is now going to be a tendency of the drive of air from rural areas to urban areas due to pressure gradient force. The air is going to be driven into the urban area from the surrounding rural areas because there's low pressure. The implication is there's now convergence in the urban area and the air is going to uplift and is going to diverge in the upper atmosphere like that. So as the air converges and diverges in upper atmosphere, it also implies that the pollutants which are being released by vehicles, which are being released by industrial activities, by construction activities taking place, they are going to be also displaced upwards with the rise of the converging air, such that the pollutants are in upper atmosphere. They are mainly in the upper atmosphere, high in the atmosphere, like that. That's the concentration of the pollutants during the day. So that is what is implied by this. There is incoming air from the surrounding rural areas. The incoming air converges and it diverges in upper atmosphere such that the pollutants are spread mainly in the upper atmosphere and they are spread right across over a wider surface area. And during the night, remember pollution domes, when you're looking at this, the implication of these arrows is that there is subsiding air or there is sinking air. When we talk of local climates of urban areas, they are mainly felt, like these pollution domes, the implications, they are mainly felt during the winter season. Remember, during the winter season, we are relating to the presence or the dominance of the Kalahari high pressure cell. The typical high pressure cell that occurs over land during the winter season. So for the same dimension, for the same reason, we are saying it's winter season, and in the very same season, that is where we find the dominance of the Kalahari high pressure cell. So the Kalahari high pressure cell is also active during this very same moment. During the day, the ground is heated and the air can uplift because of the low pressure. But at night, there is no more insolation, which means the urban area temperatures are no longer high. We are now experiencing terrestrial radiation or long wave radiation in such a way that the temperatures will normalize. They will become low or they even become lower than those of the rural areas. So as a result, you tend to find that the Kalahari high pressure cell starts to force the pollution dome further down. It is forced further down by the sinking air, such that the pollutants now are now very concentrated. They have been lowered because the sinking air is now stronger at night, and as a result, people are now affected by the pollutants during the night. During the day, they are dispersed and people are less likely to be affected by the pollutants. But at night, that is when the effect of the pollution dome is strongly felt because the pollutants are now concentrated. They have been lowered by the dominance of the sinking air from the Kalahari high pressure cell, which makes it, them concentrate close to the ground surface and ultimately affecting the health of people. Right, that's the idea. Let's answer the questions. The first question is saying the air pressure will generally be higher or lower in the urban area compared than, we have talked about that. In the urban area, it is going to be higher, like what we have seen on the illustration. The temperature difference between the city center and the rural area is, we just go to our graph and look here. If we check here, this is slightly below 34, which means let's estimate it at 33 degrees Celsius in the rural area. In the urban area, if you can check here, you can estimate it around somewhere there, 38. Around 38 degrees Celsius. What's the difference? 38 and 33, our difference is plus or minus 5 degrees Celsius. The sketch shows a typical, is it day or nighttime conditions? We have talked about that. This happens during the day. Number 124. Cool or warm air moves from rural area to replace the rising air. We have also talked about that. The presence of vegetation, the presence of natural surfaces, water bodies in the rural areas will result in cooler conditions. Right, the great vertical dimension of the heat island shape is influenced by strong, is it subsiding or rising air? Vertical dimension, we are saying, why is it tall like this? This vertical dimension compared to this dimension here. It's lower during the night and it's very pronounced vertically during the day. It's caused by rising air. Right. That takes us to the end of question number 2.1. Let's move on to question 1.3. That was 1.2. We're moving to 1.3. Right, 1.3 is talking about the tropical cyclone. I'll just give a brief explanation of tropical cyclones, how they operate, how they happen to exist, and the general information about tropical cyclones. Then we look at our questions. Right, this is tropical cyclone Chido. And we have our satellite image, and also we have the path which was followed by that tropical cyclone. And you can also see that it's a tropical cyclone in the southern hemisphere. But what you need to note here from the satellite image, over the satellite image, you need to check on the path which was followed by the cyclone. It followed that path into Mozambique. And if you also see it's here, it shows the development stage, which means it has reached maturity. It is mature. Why? This is the eye of the system, which is fully developed. The eye is fully developed if you have to check on that satellite image. So it actually shows that it reached maturity stage of its development. And what else do we need to know here? Just have to check, yes. And also the evidence that this is a tropical cyclone in the southern hemisphere. If you check the circulation, it shows that it is clockwise circulation. So you also need to check on the text which is provided, which talks about when it was formed and how it developed, and when it made a landfall in wherever it is of interest. It says tropical cyclone Chido caused widespread devastation across the southwest Indian Ocean. Forming on the 5th December 2024, Chido intensified rapidly with the development of torrential rainfall 176 millimeters in 12 hours. And strong winds exceeding 200 kilometers per hour. The cyclone passed north of Madagascar before striking Mayotte on 14 December. Chido continued its path, making a landfall in Mozambique on 15 December before dissipating on 16 December. Then this one, it also shows us the cross-section of the tropical cyclone, and where we are seeing that there's an eye at the middle of the system, here. And as we move away from the eye, we tend to find that there is a disparity in wind speed. If you check, this illustration here is showing us our wind speed. Our wind speed is actually very high around the walls of the system, and it declines the further we move away or we increase our diameter away from the center of the system. This radius from the center of the system we see from 50 meters, 100, 150 to 200. The further we move away from the eye, the speed is also declining. The same happens on either side. The wind speed is very strong at the eye wall, but however it declines as we move away with distance from the center of the system. And at the center of the system, actually the wind speed, look at where it is. It is just normal. The wind speed is very low, which is even below 40 kilometers per hour. So that's how the wind speed in a tropical cyclone is featured like. Then we also look at the atmospheric pressure. If you see a cyclonic system, we said it's a low pressure system. So which means this system is a low pressure, implying that the center of this system is a low pressure cell. And for it to have energy, it sustains on pressure gradient, which comes from the outer parts of the system. So if you check, our pressure on the outermost part is higher, but as we go towards the eye wall, towards the wall first, it declines. And as we get into the center of the system, the pressure also becomes very low. The same happens on either side. Pressure is high away from the center of the system, and it declines and drops steeply as we get into the eye of the system. That's basically the interpretation of the tropical cyclone. And what you must also note there is, in the eye, there will be clear conditions. We won't be having unstable, we will be having stable weather, clear conditions, sunny conditions, stable weather, where there's no precipitation in the eye. But by the eye walls, we will be having very strong winds and very heavy rainfall. That is where the spiraling of the air will be taking place and the formation of cumulonimbus clouds that result in the formation of very heavy rainfall associated with thunderstorms. Right, that is the basic interpretation of tropical cyclones according to the infographic. Let's go to the questions. According to the extract, over which ocean did tropical cyclone Chido develop? We are told here that over the Southwest Indian Ocean. So our answer is there is just extractive, is just taking it from the extract. During which season did tropical cyclone Chido develop? General understanding of tropical cyclones, you must keep it in mind that tropical cyclones occur in summer, but most predominantly in late summer. But for the sake of this, it's a specific. Let's check when did it occur. It says forming on 5 December. 5 December, which season is that one? That is summer. Right. Calculate the lifespan or duration of tropical cyclone Chido. How long did it last? It formed on 5 December, made a landfall in Mozambique on the 15th, and dissipated on the 16th. So we are saying the lifespan of this is from the 5th of December to the 16th. How many days are here? That's the question. We want to look at the number of days that this tropical cyclone Chido lasted. So if we say 12 minus 5, it gives us 11 days. But 11 days are exclusive of either the first day or the last day. Remember, if you are subtracting, we are excluding either the first or the last. If you are subtracting directly, 15 minus 5 is going to give us 11. But in actual sense, the duration of this is 12 days. Because we cannot exclude the last day. Either, if we subtract, it's either we are excluding the first day or the last day. But in this instance, all days are inclusive. We are starting to count from the 5th until we get to the 16th. So that gives us 12 days. Right, refer to the satellite image and explain the reason for the direction of tropical cyclone Chido. We said our path is indicated by that line there is indicating the path that was followed by tropical cyclone Chido. Right. This is the path as indicated by this. This is indicating us the path that was followed by the tropical cyclone. It actually moved in that direction. From there, it got to Mayotte, it passed there, it went further to Mozambique. So, which direction is this? We are saying it moved from the west, the east to the west. Or we can say it moved in a westerly direction. What is the reason for tropical cyclones to move from east to west? That is the question. What makes tropical cyclones have a tendency of moving from east to west? If you check, if I'm to take you back to the global air circulation, you can quickly remember. I'm just going to make an illustration, a quick illustration. If we refer back to global air circulation, we can remember quickly that on our globe, right, we have this, our equator at 0. We have our subtropical at 30 degrees to the south, our subpolar at 60 degrees to the south. At 90, we have our polar, and also we have at 30 to the north, our subpolar north, our 60 degrees to the north, our subpolar north, and then at 90, we have our polar north. So we are saying tropical cyclones, they happen to exist within this region here and this region here. And remember, they don't effectively form within 0 to 5 degrees of the equator. Why? Because of limitation of Coriolis force. They form from 5 to around those regions. So we want to look at what is the reason in this belt where they form, which makes them move from east to west. Like that. We are saying they move in this direction. In this direction. So automatically it means the planetary winds in this belt are responsible for the driving of the weather system. Which planetary belt is this? This is a belt of tropical easterlies or the trade winds. So the reason why tropical cyclones move from east to west is they move under the influence of tropical easterlies. If you see the planetary wind here is also from east to west. So as these winds blow in this direction, they are the ones also responsible for driving the weather system. So they move under the influence of tropical easterlies or the trade winds. That is the reason they are driven by tropical easterlies, or what we call the trade winds. Right, refer to the graph and state why the eye of the tropical cyclone is calm and clear. On the eye of the tropical cyclone, it is clear. Why is it clear? If you check here, the reasons why this becomes clear, I'll just try to summarize there. why we find clear conditions in the center or in the eye of the system. Right. Why it gives us clear conditions is that the air descends. In the center of the system, there's descending air. The air is actually sinking in the center of the system. That is number one. There's subsiding air, or the air descends or sinks into the center of the system. And there's no condensation automatically. If air is sinking, there's no condensation. We expect condensation to take place as the air is being uplifted, but it's the opposite. The air is sinking. So automatically, there is no way we can experience precipitation or unstable conditions. And we also look at a situation of the air heats up. It heats up adiabatically. The air that sinks there. So there's no chance the air actually loses any moisture. If it has any moisture, it is going to lose the moisture as it heats going downwards, as it sinks. So there's no cloud formation there for that reason. No clouds can form in that situation. That is why we have clear conditions in the eye of the system. Right. Then the next question says, explain how the moisture content and high temperatures over the ocean contribute to the formation of heavy rain in the eye walls. In the eye walls. Right. It talks about why there is why moisture content is actually high. It's actually high, and high temperatures over the ocean contribute to the formation of such. Right, we talk about rate of evaporation. Moisture content is caused by high rate of evaporation. It's warm over the ocean, which also means there is a high rate of evaporation. Which facilitates cloud formation. And also, if you look at the fact that we have rising warm air, causing large-scale condensation. There will be high levels of condensation taking place because of the rising warm air. And for that reason, again, we talk of the presence of high humidity in the air. When we have high humidity, it means it will result in effective formation of clouds, which are rain-bearing. Which tend to produce heavy rainfall because the air is heavily humid, is having a capacity to contain a large volume of water vapor. And for the same reason, it's going to cause large-scale condensation and heavy clouds are going to form. And as a result, we are also going to experience heavy rainfall being experienced. And also, we can talk of the high temperatures. They contribute towards the release of latent heat in the system. And also we can talk of convection currents. The convection currents, they also contribute to the upliftment of the air, which is warm and moist. And as it is affected by the currents, it is forced to reach the dew point, and ultimately we are going to experience a situation of large-scale condensation and heavy rainfall. Right, that is just a summary of what you can write about for that question. Let's look at number 1.4. 1.4 is a question on the Berg winds. Right. Why is the coastal law referred to as a traveling disturbance? A traveling disturbance, why is a coastal law? If you look at what we call the coastal law, we are looking at that low pressure cell, which is indicated on the edge of land and water. So whenever you see an L, which is on the edge of land and water, that is a coastal law. So the question is saying, why is it a traveling disturbance? It is regarded as a traveling disturbance because these coastal laws, they move along the coast. It's there, it comes here, the same coastal law, it moves, it's there. It moves again, now it's there. They move, that's the attendant of the coastal law. They form from the western coast here. That is where they form. And they will dissipate in the eastern coast. So they are traveling in the sense that they form from the west and they travel along the coast, going towards the eastern coast. That is why they are regarded as traveling disturbances. As they move, they cause changes in weather conditions along the coastal areas. So it's traveling in the sense that they form on the extreme western coast and they travel along the coast, causing changes in the weather conditions, going towards the east and where they will dissipate around Mozambique there. Right. Refer to the station model. What is the maximum temperature? Our temperatures, we see them from these two digits here. The maximum temperature is the air temperature, which is 32 here. And remember, your temperature is indicated is in degrees Celsius. Do not leave units of measurement. On the synoptic map, we don't put units of measurement. It's just 32 as a number. But you understand that our temperature is always represented in degrees Celsius. Right. We move on to the next question. What causes the Berg wind to be warm offshore wind? To be warm offshore wind, we understand that the Berg winds, they are hot and dry winds. Why do they become warm offshore winds? Right, the first thing that you must note here, they move from the interior to the coastal because of pressure gradient. They are driven by pressure gradient. That is why they are offshore. Where is the pressure gradient? There is high pressure over land and there is low pressure caused by the coastal law. So as a result, they tend to move from the high pressure Kalahari, high pressure cell, and being driven to the coastal law. And as they go down the escarpment, they heat up adiabatically. They are heated up adiabatically, which means that the changes in pressure result in the rise in the temperatures of the Berg winds. They heat up adiabatically as they descend from the escarpment. That is the reason for why they are warm. They warm because of adiabatic heating that happens on the escarpment as the air is descending from the plateau over the interior towards the coastal areas which are lowly elevated. That is basically the reason. And question number 1.44, it says, in a paragraph of approximately 8 lines, explain the negative physical impact of Berg winds on farmers in the area. How are farmers in the area impacted by the Berg winds? We understand that the back winds, they are ultimately hot and they are dry. So how do they impact on farmers in the area? That is basically the question. We can talk of the farmers experiencing serious challenges with their crops. Crops may wilt or can even die due to insufficient water. Remember, if there's a hot, dry air, it facilitates high rates of evaporation, meaning to say ground moisture is lost, and that is going to cause crops to have moisture stress or moisture deficiency, and that is going to affect the crops. Or we can look at they bring with them drought conditions. The back winds, they result in drought conditions, and as a result, there is likely to cause crop failure. Or in terms of yields, they might be reduced. Farmers will not reap as expected because of the drought conditions, excessively dry conditions that are caused by the back winds. They're going to affect the crops. Crops can fail or they can result in reduced yields for the farmer. Then you can also look at livestock, also affected. We also have typical livestock health issues due to high temperatures. Some livestock will have heat stress, and ultimately it is going to affect the quality of the livestock. And some vulnerable livestock might even die because of the excessively high temperatures. So it's a negative implication on the farmer. And also water quality is affected. The general temperature of the water is going to increase, and that is going to affect the water quality, which is also going to affect agriculture. And you can also look at increased cost of irrigation. Can result in increased irrigation costs. Since there is excessive loss of moisture from the ground, it also implies that more water has to be applied to the ground, which adds on cost of irrigation to the farmer. And also it increases risk of fires. Risks of fires. And understand those fires, they damage both crops and livestock. So there's increased risk of fires because of the wildfires, because of the back winds, and they ultimately destroy the livestock and also destroy the crops and also destroy grazing lands, which is a negative implication on the farmer. So those are some of the problems that we can face as a farmer because of the presence of back winds in the coastal places. That was question number 1. We move on to question number 2. Question number 2 is giving us an illustration of a number of some drainage patterns. We're going to use those patterns to answer the questions. Right. If we look at these patterns here, we are seeing how they differ from each other in terms of the arrangement of the streams. Right. The first one is saying rivers flow away in all directions from the peak, which is a central elevated point like a hill or a dome. We are explaining something like this. Let's say maybe this is a volcanic mountain, and then maybe there's a volcanic lake on top. And rivers are starting from the top, flowing in all directions from the focal point, which is high lying. Which one best describes this scenario of streams flowing from a highly central point into different directions? That qualifies to be E. Main river run parallel to each other and have short tributaries that join at 90-degree angles. If we try to look and analyze, we can actually see that it's describing this kind of drainage pattern, which is trellis. So it's C. Tributaries that join the main river at acute angles and which form on rocks that is uniformly resistant. Joining at acute angles and which forms over uniformly resistant, that is a dendritic pattern, which is typical of F. So our F is the one which is best described by the statement number 3. Then number 4, forms in highly jointed rocks where the main river and its tributaries have right angle bends. Highly jointed rocks, main river and its tributaries have right angled bends. We can see that this is a right angle, this is a right angle, those ones are slightly right angles. That is a typical of what is being described here, which is a rectangular pattern. So rectangular pattern is D. Rivers and tributaries flow in roughly parallel lines on a slope with a steep gradient. That describes parallel drainage pattern, and our parallel drainage pattern is B, this one here. Right, so it's B for that one. All right, this last one here, the implication is these streams are starting from high-lying areas surrounding, and they are feeding into a low-lying area. Maybe it's a lake or it's a marshy area. It's the opposite of this one. This one, they are flowing from a high-lying area outwards. These ones are flowing from outlying high-lying areas into a central point. Right, let's look at question number 2.2. Question 2.2 is talking about the courses of a river or the stages of development of a river. Our river systems are basically divided into 3 segments, which is number 1, the upper course, which is the youthful stage, the middle course, which is the mature stage, and the old age, which is the lower course. So we want to look at the statements that best describe the courses of the river. Right. Deposition is the main fluvial process in the dash course. Automatically, deposition happens here where gradient is gentle and velocity is very low. So we tend to find deposition dominating in the lower course. The middle course is dominated by dash erosion. Middle course is dominated by lateral erosion. I'm going to explain those types of erosion at the end of the discussion here. Fluvial landforms in the lower course. In the lower course, what do we typically have? We typically have natural levees, which are the natural embankments by the sides of the river caused by deposition of material. Right. Permanent base level of erosion is at dash meters above sea level. The permanent one is at 0 meters, which is the level of the sea. A transverse profile representing the middle course. Between Y and Z, automatically the middle course is Z. Right, about types of erosion in the river. We have 3 main types of erosion that happens along the river course. Number 1, we have vertical erosion. Number 2, we have lateral. Then number 3, right. What we're talking about here, we're saying for us to realize this type of shape of the cross profile of a river is we realize the lateral cross profile of a river by the nature of erosion that takes place in that segment of the river. Right. So what happens mainly in the upper course is there is vertical erosion. Vertical, it means is downward erosion. Downward in the sense that it acts downward like that, which means it is responsible for deepening the river channel. The river channel becomes deep. That is why you tend to find valleys in the upper course. They are V-shaped. Why? Because there is more of vertical erosion. This valley is not widening, but is rather getting more deeper and deeper. That is why you tend to find landforms like gorges in the upper course. It's because of the dominance of this type of erosion, which is vertical. Then lateral, as we go to the middle course and the lower course, we have what we call lateral erosion. This is now erosion responsible for the widening of the river channel. It acts on the sides of the river to make the river wide. So its sideway erosion is responsible for widening the channel. That is why you find that in the middle course we said is this shape. This river is wider compared to this one. This is a V shape, this is a U shape. And what we call headward is the type of erosion that happens at the river source. It migrates the source and is responsible for lengthening of the river. The river becomes longer and longer because of headward. Why? Because the source migrates. If a river source is here, the source is going to supply water and the river is going to flow like that, starting from this point. But next time, the source is going to migrate. Our source is now there, which means this is an additional distance covered by the river. The next time the source migrates, our source is now there. So this is headward erosion. It's responsible for lengthening the river channel. Right, that's basically the idea of the river erosional processes. Let's go to number 2.3. Question number 2.3 says, refer to the sketches showing river capture. There's a cross-section of watershed before river capture. There's a harder rock along Y and softer rock on X. And then there's a height there. After river capture, we are seeing that this is a captured stream and then a misfit. So the implication is before river capture, this stream was continuing like that. It was attached like this. And it also implies that this stream here was also having its course like that and also maybe advancing towards the watershed. So what it implies is these two river systems were separated. This watershed was continuous. They were split by this high-lying area. River Z was flowing on its own as an independent river, and this one also was flowing on its own as an independent river. There are two river systems which were distinctively separated by the watershed. But however, because of lot of headward erosion, this stream was able to headwardly erode into the watershed and managed to intercept the water from the other side. That is why we are seeing now that the watershed is now broken here, meaning to say there was effective erosion of the watershed, and this stream managed to capture water from this stream, and now the water is diverted. This one is no more there. The water now has been diverted effectively into this other Z stream. That's the implication of what is illustrated there. Then what is a watershed? You can see there. A watershed, you can define it simply as a high lying area that separates two river systems or two drainage basins. That's a watershed. A watershed basically is a high-lying area that separates one drainage basin from another or one river system from another. Do not confuse a watershed with an interfluve. An interfluve basically is a high-lying area, but it separates streams within the same drainage basin. An interfluve separates streams within the same river system, but a watershed separates two different river systems or two different drainage basins. That's the difference there. Refer the cross-section of the watershed. Would the capture stream flow on X or Y? The capture stream, the one that advances, obviously to flow over X. It will flow over slope X. And give a reason. Number one, a capture stream has to flow over steep gradient. It effectively erodes headwardly over a steep gradient. And also, if you check there is soft rock. That is the basic evidence. So, for this to effectively erode, it needs to erode over steeper gradient. This stream will advance headwardly over a steeper gradient, and also the nature of the rock here is soft. If it was not soft, it means this river cannot effectively erode headwardly, and then it would not be able to capture the rivers on the other side of the watershed. Refer to the sketch showing the conditions after river capture. How did the misfit stream form? How did the misfit stream form? The misfit is this one here. It's misfit from its original. The original supply of water was there, but it's cut here. There's now a wind gap in between. So how did this form? This one is formed just because of the beheading of source of water supply. The source of water supply here has been beheaded from it. That is why it's now become a misfit. It's now trying to sustain on its own without its original source of water supply. If there are no stronger tributaries to supply that stream, automatically it is going to dry up because of the beheading of the source of its supply of water. It has been cut off from its supply of water. In a paragraph of approximately 8 lines, explain how the flow characteristics downstream of Z will change after river capture. Of Z, we are looking at Z stream. Z is now having supply of water from 1 and supply of water from 2. What is going to happen after this? What is going to happen to the features of this river from this point going downwards? Here, what is going to happen? Right, there are dimensions that we need to look at there that will guide us to look at those changes that are going to be realized, because we need to look at the flow characteristics. Right, number one, we need to look at the discharge. What is going to happen to the volume of discharge after stream capture? And we also need to look at the energy. We also need to look at the aspect of velocity. We also need to look at other aspects like rate of deposition. We also need to look at aspects like rate of erosion. We also need to look at aspects like the load segment. You can also look in the dimension of nature of flow. If you look at those ones, those are the flow characteristics. Automatically, because there is now an extra supply of water, the discharge is going to get higher. It is going to increase the volume of discharge. The amount of water in the stream, in the channel is going to increase. There will be higher discharge. Then the energy, it is going to have more energy. Why? Because there's now more water flowing in the channel. Then its energy is also going to increase. And because of more energy, the river can rejuvenate. We can experience rejuvenation. We see the river regaining its erosive power because of increased energy due to an increased supply of water. The velocity, the speed of flow of the water is going to increase automatically because now the water volume is high. It is going to flow faster. Deposition levels is going to be very low. It's not going to deposit material because now it has more energy. There's now more water. So deposition levels are going to get lower. Erosion is going to increase. We're talking of rejuvenation there. It now has more energy. It can now erode more because of the more energy that is gained through additional supply of water. About the load, it can now carry more load segment. More load can be transported there because of, and heavier loads can also be transported because it now has the energy. And then the nature of flow, the flow becomes turbulent because now the channel is being eroded because of increased energy, and the nature of flow also, it becomes a turbulent. If it had reached the stage of laminar flow, then when it rejuvenates, it goes back again to a turbulent flow. Right, I think that's the idea behind that particular question. We move on to question number 2.4. It's a case study on the need for integrated water resource management. We're not going to go through the text. We're going to answer the questions. Identify two of South Africa's neighboring countries that are part of the Limpopo River Basin catchment area. This one we extracted from the map. There's Zimbabwe, there's Mozambique, and there is Botswana. Those are the indicated three. According to the extract, suggests one human and one physical factor that threatens the Limpopo River Basin's water quality. Right. One human and one physical. If we come here, we tend to find that it says, paragraph number 2, located in a region that is classified as arid to semi-arid, the water resource, both surface and underground sources, are under severe pressure because of negative impacts associated with climate change and constant increase in water demands from various sectors. So this one is a natural factor. This one is a human factor. So if you are looking at the human factor, there is increase in water demand. Then a physical factor, there's climate change. Right. 243, what percentage of the Limpopo River Basin's water is allocated to the agricultural sector? It's again extraction. Agriculture is taking 60%, which is there. Suggest 3 sustainable water resource management strategies that could be implemented to ensure healthy water quality is maintained in the drainage basin. Right, that one there is a question that requires you to openly think of sustainable and justifiable measures that can be put in place to try and improve the water quality in the basin. So we can look at strategies like education. We educate the people so that they take responsive action towards sustaining the quality of the water. Or we can use buffering as another measure. We can try to fence along the rivers to avoid human activities interfering with the river, or to limit settlement and dumping encroaching into the river channel. And also we can look at other measures like incentives to reduce pollution. We incentivize ways of reducing pollution like recycling, so that at least we minimize the amount of pollutants on the ground that will ultimately find their way into the rivers. And also we can look at legislation, enactment of different laws that prohibit pollution of the drainage basin. And also we can look at heavy fines for offenders. If we see, for example, companies dumping waste into the rivers, they must be fined for such an environmental criminal act. Then also, we can also look at water testing. We can also regularly test the quality of the water to see if there are any pollutants which are being added, so that we find preventive measures towards such pollutants. And also we can look at protecting wetlands. We limit construction in wetlands because that is where also our water is accumulated from, such that we also have an effective and efficient guaranteed supply of clean and quality water. Right, that does not mean that is the end of all what you can mention. There are other things that can also be mentioned, which unfortunately we could not ultimately look into, but there are several other methods that you can also think along, and you can also present them as valid responses to the question. Right, we move on to question number 3 on settlements. Right, question number 3 is showing the sphere of influence for settlement A, B, and C. Right, if we look at settlement A, B, and C according to the graphs at the bottom, right, what you must understand there is we have the basics of spheres of influence. Right, a sphere of influence, we are saying, where does a particular settlement draw people who support the services that it offers? How far are people prepared? The range. So the sphere of influence, we are saying, the area where a settlement gets its support from, people who give support to a particular settlement. So if you look at settlement A, in terms of population, it's here on the graph, which means it has a lower population. It's low, high. A is here, which means the population is low. Then if you look at B, is here. Basically, the population is mid. A is low. Then settlement C, if you see now, it has high population. So it implies that A is a smaller settlement, B is a moderate, and C is a bigger settlement. Then the same also happens to number of functions. We are looking at the functions which are provided in that particular settlement. So A, if you look at the number of settlements, there are few. It provides very few functions. B, it has moderate number of functions. C has got many functions. That's the interpretation. And if you are to look at the spheres of influence, we are saying A, people who are supporting services in A are coming from this particular region here, which is basically a smaller area. And for B, people supporting services in B, they are coming from this area, which is slightly bigger. And then people supporting C are coming from all over this region here, inclusive of A and B. Right, that's the impression of what is shown by that illustration. Let's answer the questions. The settlement that has largest sphere of influence, the largest sphere of influence. Automatically, we have seen on the diagram there that who has got the largest sphere of influence. Automatically, that is settlement number C. If you can see how big is the influence of C, it's even covering both A and B. So it's C, settlement with the smallest range. The range, you are saying the distance that people are prepared to travel to get the services. Smallest range, it means it's in A. People can only travel this distance from the edge to there, the edge to there, which is shorter. If you compare to B, people travel longer comparably. If you look at C, people are prepared to travel the longest. One can travel from this extreme end here to get to C, which is a very long distance. One can travel from here to get to C. So the range is smallest for settlement A. The settlement that offers the least low order services. Least low order services are offered in A, that is the smallest settlement. The smallest settlement mainly offers convenient products, basics which are used on a daily basis. The settlement with the second smallest population is automatically B, according to our graphs. Settlement that has the most number of high order functions. High order functions, we find them in C. When we find high order services or functions, there is also the issue of a wider range. People are prepared to travel for long distances to acquire services or to get functions which are of high order. Comparably, we are saying the distance that one is prepared to travel to go to a primary school or to a preschool is shorter compared to the distance that one is prepared to travel to go to university. University is a high order function. Primary school is a low order function. It doesn't make much sense for one to travel for 60 kilometers to go to a primary school. It does not make much logical sense, because those are low order functions and primary schools are almost everywhere. But for universities, you can be prepared to travel from Joburg to go to the University of Cape Town. It's a high order function. That's the sense there. The range differs with the level of the service. High order services have got a bigger range. People are prepared to travel for longer distances. Or even the same with goods. Let's say, for example, we are comparing bread against maybe a latest model of a car. You cannot travel a distance to go and buy bread. You buy from the next convenient shop because it's a low order good. And you don't take any considerable effort to make comparison of prices. But for you, when you want to buy a car, you can go and buy a car from somewhere as far as 500 kilometers because it's not a low order, it's a high order product. Right, let's look at the next question. Next question saying is looking at the gross profile of an urban area From the rural urban fringe to the residential, the green belt, we have the CBD residential. Right, it actually shows us the side view of an urban area, how the urban land use zones are structured as we move out of the central business district. Let's answer the questions. The urban profile shows the dash of a city. What does it show? It actually shows us the side view of a city. The urban profile, this is a side view of a city. The central business district, the CBD, is characterized by, let's look here. Our CBD is here. We can see in the CBD, there are high-rise buildings. Why do we have high-rise buildings? Land value is expensive and there's no more space for expanding horizontally. And also the density of buildings is actually high because of limitation of space. The buildings are closely spaced for the reason that there is no more space to waste. Right, let's look at the possible answers. The question is saying the CBD is characterized by high building density. That is very correct. Low land value is very wrong. Low concentration of commercial activity is also equally very wrong. And low degree of accessibility, that is also wrong. So the correct response from the CBD is A. The transition zone has and is featured by our transition zone is not indicated here, but is indicated here, this area. The transition zone is a zone of change. As we are moving out of the CBD, you tend to find that there is a zone with some mixed settlements, or some mixed functions rather, not settlements. Is a zone with some mixed functions. You cannot figure out whether it's still commercial, or it's now industrial, or it's now residential. That is the transition zone. It's in the phase of change. Either the urban area is expanding into the area or the urban area is declining away from that area. So it's actually a zone with mixed functions, which is transitional in the sense that it's in the form of change. It does not have a specific land use pattern, but it has some mix of land use patterns. And also that is typical of the area where you find that we typically have abandoned buildings or illegally invaded buildings in such a zone, or buildings which are lowly maintained in that particular zone for specific reasons. That is basically the zone of transition. So we are looking at this. It says the zone of transition has dash and is characterized by whatever. So we want to look at the first part. Mostly high order functions is wrong. It has got mixed land use. And what is the other feature? Is it invasion and succession? Is correct. And commercial centralization? No. What we call invasion and succession, we are saying one function invades into another function. Let's say, for example, in that zone, there was a residential house. It was a residential house initially, but the urban area is extending outwards. The CBD is extending outwards. If the CBD is extending outward, it automatically means that commercial purposes are more profitable than residential purposes. The owner of the house will even opt to sell off the house for commercial purposes than for residential purposes. So it means the residential function has been invaded and now has been succeeded by a commercial function. That is invasion and succession. There is takeover of a particular function, a function which is non-viable in that particular section is going to be invaded. We cannot have land use which is non-profitable, when the CBD is bringing in and is in demand of more profitable commercial purposes or commercial uses, then it automatically means that the more profitable use is going to invade into that particular function and is going to succeed that particular function. Right, I think that is clear. So that is the option there is for that response is B. Right, moving on to the next question, it says dash is a factor that determines the location of a heavy industrial land use zone. Heavy industrial land use zone. We understand that heavy industries, they require large space for expansion. They also require areas with water supply for the cooling of the machinery used in the manufacturing processes. They also have to locate away from the CBD and residential areas for reasons that they cause high levels of pollution in terms of noise and air. And also some of the activities that are done there are equally dangerous. They cannot be done close to residential areas. They also need to be linked to transport routes like the railways and the major roads for the supply of bulk raw materials, and also the supply of the finished for the transportation of the finished products. All those factors are factors that determine the location of the heavy industrial areas. So if you are to look at this, we can safely say the correct response from this is D, located close to access to bulk transport facilities. Urban sprawl. When we are looking at urban sprawl, we are looking at uncontrolled growth. Uncontrolled, or we can look at it as a formless or shapeless. That is urban sprawl. The urban area just grows anyhow without any specific shape. It does not follow any specific planning. People just develop the way they want in any direction. That is urban sprawl. It causes a physical change in the dash land use. It affects the rural urban fringe. If you check here, if the urban area is sprawling, we are invading the rural urban fringe. It is going to be affected. Right. Question 3.3. It is abandoned buildings in Passant water. It talks about rural depopulation is Passant water. What is rural depopulation? When you see this word depopulation, remember of decline. So rural depopulation is the decline in the number of people staying where? In the rural areas. Or we can call it the countryside. That's rural depopulation. The size of the population is declining. It's a decrease in the number of people staying in the rural areas. The decrease or the decline in the numbers of people who stay in the rural areas, that is rural depopulation. Give evidence from the photographs that rural depopulation has taken place. We want to use photograph evidence here, and we must figure it out from what we are seeing. There's rural depopulation evidence. If you look at the look of the vegetation here, if this place was functional, automatically it would have been cut off. So it's one evidence that you have overgrown vegetation. People have left the place. There's overgrown vegetation around this place, which shows that it's not working. And if you also look closely, ultimately this railway station is not functioning. Railway station is not functioning. There's no evidence of activity here. Which is also absence of human activity. We expect the railway station to be busy. If it was busy, at least we would have evidence of someone around or someone doing something there around. There is absence of human activity completely. It's abandoned. Or if you also look at here, these windows are broken. If there were people who are benefiting from the facilities, they would have repaired that. It means they were just broken and they were just left to dilapidate. And also, if you look at, there is also some form of graffiti. The walls are no longer looking nice. They are fading off. Paint is fading off or peeling off. All those are pieces of evidence that you can actually see from those illustrations there, that the place has been depopulated. According to the extract, name the factor that initially contributed to rural depopulation in Patsanda water. According to the extract tells us that the town's decline began after the collapse of its primary industries, particularly agriculture and mining. That is the reason why it had depopulation. It automatically means that the people who were sustaining in that particular geographical space were reliant on agricultural activities and mining activities. So because of typical problems of climate change and all those other challenges, agriculture has become unprofitable for them. It's no longer viable for them. Then the only way to sustain better is to go to cities and towns. So they've decided to move out. Mining, maybe the mineral resource has got depleted. It has finished at some point, or maybe it's now very expensive to get to the levels. Maybe it's now very deep level mining, which is now expensive. So the effort required there to extract is now even more costly than the benefit of the sale of the product. So there is no more benefit of continuing with mining. So the collapse of the industrial primary activities led to the decline of the population. What are the economic consequences for rural areas when basic amenities such as general dealer shops close? If we have general dealers closing, what is going to happen? Automatically, it means there will be job losses. People who will be employed in those general dealer shops, they've automatically lost their jobs. And then what is going to happen there? There's going to be poverty. They don't have a source of income, and also that is going to lead to poverty in the area. And ultimately also, that is also going to lead to decline in property values. The property values, they decline if there's no activity. There's no one who wants to occupy a space where there's no activity, or wants to buy a property where there's nothing happening. So the value of the property is going to decline. And also the problem of prices. General prices are going to rise. High prices for the consumers due to limited competition. If, for example, there were maybe 5 general dealerships and 4 of them decide to close, and then there's only one remaining, that one is going to overcharge because there's no more competition. So it's also a threat. There's also a problem of reduced expenditure. If people are fewer in the area, it automatically means that there is also going to be reduced expenditure, and also people are losing their jobs. The expenditure is going also to reduce. Right, those are some of the things. And also we can talk of the problem of travel costs. To access commodities or to access products or goods. If the retail shops are closing, automatically it means people have to travel to the nearby available dealers so that they could access the basic goods that they will be in need of. So automatically it means that they are going to have an extra cost of transportation. If it was a walkable distance and then now you have to use transport to get there, then it's an extra cost on top of the buying price of the commodity in question. Right. That takes us to number 3.3.5. Explain the negative social impact of rural depopulation on rural settlements. Our question here is specific. This one was looking at economic consequences. Remember, there's a difference between economic consequences and also social. When you're looking at social impacts of rural depopulation, we need to look at how the society is affected. Social impacts. We are looking at the social impacts. We are saying, how is the society affected? How is the society affected? We look at things like disruption of family, disruption of family structures. Family structures are disrupted because of the movement of people from rural to urban areas. The family will no longer be united. It will be disrupted for that reason of movement. And also, we can also have problems of brain drain. People who are skilled, who have got knowledge in the rural areas, are going to move out. So it's also a typical social problems. We'll end up not having people with a skill because all the skilled people will move out for the reason of wanting to go and use their skill profitably in the urban area. And also we can look at the problem of aging population. Usually the active ones are the ones who move to urban areas. The elderly and the youth, the young ones, they stay behind. So who has to take care of the elderly? There's a problem of the aging population. And also we can look at other issues like decrease in the quality of life. The quality of life is going to decrease. Or we can talk of problems of social isolation. All those typical social problems can be experienced as a result of that problem of rural depopulation. Let's look at question number 3.4. Question 3.4 is refer to the graph and extract on informal settlements as an urban issue. Right, we are looking at the number of fires in informal settlements against the change in time from 2016 to 2024. This is actually a worrying concern of growing fire concern in informal settlements. Right, we're not going to go through the text. We're going to answer the questions. According to the graph, state the trend of the number of fires in informal settlements from 2016 to 2024. When the question asks you of a trend can either be increasing, decreasing, or constant. That is what the question requires you to find out. If they ask you of the trend, is it increasing, decreasing, or it's maintaining the same, is constant? So from 2016 to 2024, our graph is positively sloped. You can see there. So our trend is increasing. Give two reasons from the extract why fires spread quickly through informal settlements. Let's find out. Paragraph number 2 says, informal settlements are typically densely built. And people's homes are built from highly combustible or flammable materials. These are the reasons. The reason number one is that they are densely built, meaning to say they are too close to each other, such that when there is a fire in one of the structures, the fire can easily spread to all other structures because there is barely enough distance between them. They are densely built. And number two, the material that was used to construct those structures, or that is still being used to construct those structures, is highly flammable or combustible. Mainly it's wood and plastic material. Plastic is highly combustible. It catches fire easily. So for that reason, the fires become uncontrollable. How does a lack of proper infrastructure hinder emergency services from reaching informal settlements? How does lack of proper infrastructure? Proper infrastructure, we're looking at the different forms of infrastructure that must be availed to a decent settlement. So it's lacking. And how does it hinder emergency services? Maybe there's a fire, firefighters need to assist. But there's lack of proper infrastructure. How does it hinder? It hinders, for example, it gives poor accessibility. Because of absence of proper roads, it takes time for emergency services to access those areas. They have poor accessibility, or sometimes access is limited or restricted. Some of the areas are not reachable completely. So emergency services cannot be able to get there because it's completely restricted. Or sometimes it's difficult to navigate. Some of the roads are not easily passable. It becomes very difficult to navigate to those areas. And as a result, it results in delays in response. So basically, you tend to find that with such situations, there's a problem of accessibility to those areas, or sometimes they are completely restricted. You can't find a way of getting there. So as a result, the emergency services, they will also fail to provide sufficient help in relation to the current problem being faced by the people because of such typical problems of accessibility of the area. The area is not easily accessible. People cannot easily get into a contact with the area in question where the people are in need of help. Right. In a paragraph of approximately 8 lines, suggests measures that local municipalities can put in place to reduce the challenges associated with fires in informal settlements. What can local municipalities do to avoid the typical problems of fire? Right, they can try to put better emergency services like firefighting must be improved and must be readily available, though it cannot easily access the areas in some other settlements. They can also educate the residents on the dangers of fire and how they must prevent the possibility of fires in their areas. And also we must put in evacuation plans. How can we save people in terms of fire? How can we evacuate people from the danger of fire? And also they must encourage the use of stronger building material. In this instance, we are looking at advocating for brick walls instead of zinc and wood walls. And also they must try to promote spacing. Promote spacing between houses. It must also be promoted. Or we can also look at other things like fire alarms. To alert people that there's a fire outbreak, there must be fire alarms, a fire alarm system. And then maybe in case we also need emergency shelters. In case there's a fire and people's shelters are destroyed, there's need to for a secure emergency plan whereby we can shelter people as they await maybe the reconstruction of their structures which have been gutted by fire. So we must also have a plan in place of emergency shelters. Right. I think with this, that takes us to the end of question number 3 and also the end of section A. We now need to move on to section B, which is our map work. Our map is based on the map of Agrabis with those coordinates 28 degrees 35 minutes to the south and 20 degrees 20 minutes to the east. And that map information provided there. Right, let's look at the map questions. The first question is saying the reference code of the map directly to the east. Our map in question is 2820 CB, which is in this block here, shaded. So the map to the east, this is west, this is east. Map directly to the east, we want the reference of this. What is the reference? The coordinates, they don't change. With still the same 28 degrees of latitude, 20 degrees of longitude, and our referral blocks are the ones that are supposed to change. Remember, the first letter is for the bigger block subdivision, and the second letter is for the smaller block subdivision. Why we are saying this is 2820 CB is because the bigger block is C in this, and the smaller block A, B, C, D is in block B. So our bigger block for this is D, and our smaller block is A. So it's, in this instance, 2820 DA, which is A. Then the photo number for the map of Agrabis, the orthophoto number, you find it here. This number, it represents the photo number of the orthophoto. Or if you can also go to the map, you can also find the orthophoto number. It's indicated here. That's the orthophoto number, number 7. So automatically your answer is 7, which is C. Right. The map with a scale of 1:10,000 shows a dash area with dash detail compared to the map with a 1:50,000. Comparison of these two scales, 1:10,000 and 1:50,000. This is a large scale map. It's a large scale, and this one is a small scale. This one, in terms of coverage, it covers a smaller area. And this one, it covers a big area. In terms of detail, this one shows more detail. And this one, it shows less detail. Thus, the difference is between those two types of map scales. A 1 is to 50,000 versus a 1 is to 10,000. So going to our question, we are saying a 1 is to 10,000 shows it's a smaller area with greater detail. So item number 1 and item number 3, which is B. That is our correct response. Right. We take it to the next question. Calculate the distance, which is the horizontal equivalence in meters, from point number 1 in block D3 to point 2 in block C2 if the distance is 7.8 centimeters on the map. We don't need to go to the map because we are already provided with the measurement, and we are told we are referring to the orthophoto map. Our orthophoto map, always remember, is having a scale of 1s to 10,000. Do not confuse there. So we do a quick conversion. For you to get the distance in meters, you just say your measured distance, which is 7.8 centimeters, you multiply it by 100 meters. This gives you 780 meters. Where are we getting our 100 meters? This is a short conversion for a scale of 1 is to 10,000. We are converting 10,000 centimeters into meters. We divide it by the number of centimeters in a meter, which is 100. So if we divide this, we remain with 100 meters. So if you want to convert a distance from the orthophoto map to meters, you simply multiply by 100 meters. So that gives us 780 meters. Right, number B, determine the difference or the vertical interval between 1 in block D3 and 2 in block C2. Right, unfortunately, the features are not very visible. Our 1 is said to be there, and our 2, unfortunately, for the sake of the map, is not very visible. You can also witness, even if I try to enlarge it, some of the features are not very visible, and some of the markings are not very visible. But I'll just explain and make it clear how you find the VI. What you call the vertical interval, or the VI, is the difference in height between the 2 points. So you just say the bigger height between the two. The bigger one is 625 meters. You subtract the smaller height, which is 615 meters for the two places. And it gives you 10 meters. That is your VI. VI is basically the difference in height between the two identified points. And we don't deal with negative values, always subtract the smaller from the bigger one. So 625 meters minus 615 meters, they give you a difference of 10 meters. That is our vertical interval. Then calculate the average gradient from 1 to 2. When you are now calculating the gradient, you are using the vertical interval over horizontal equivalence. You just simply substitute your VI, you got it as 10, and your horizontal equivalence, you got it as 780. So that's basically in meters and in meters. And the meter values are going to cancel each other. What is going to happen there? If you have done that, then this has to be expressed as a ratio with a denominator equal to 1. How do you make the numerator must be equal to 1? The ratio must be expressed as a ratio with a numerator equal to 1. So what must we do to 10 to make it 1? We must divide it by 10. In the same, we must also divide this by 10. So 10 divided by 10 gives us 1. As 2, 780 divided by 10 gives us 78. This is now our gradient as a ratio 1:78. Then explain how the gradient in question 1414 favored the development of the holiday resort. There is a holiday resort between those 2 points, the gradient of 1:78. 1:78, it implies that the area is gently sloping. It's almost a flat area. So how did it favor the construction of a holiday resort? Right, it's number one, it's cheaper to do construction, cheaper to build on general slopes. If you compare the construction cost of a steep slope and a gentle slope, you will see the difference. It's very cheaper to construct on a gentle slope. And also it's easier to build because it's easily accessible, because it's gentle. And also you can talk of accessibility. It is easily accessible. Either for the construction vehicles, they can easily access the area. And also it's safer to construct on flat. There are so many dangers associated with the steep sloping areas. Typical problems like landslides can affect gently steep sloping areas, mudslides, rock falls, or those typical problems. But it's much safer to do construction over flat lands. So for that reason, the holiday resort was established there. Let's go on to the next question. The Orange River is classified as is it episodic or exotic river? Orange River is an exotic river. Give a reason. What we call an exotic river, we are saying an exotic river does not conform to the climatic conditions of the area over which it is flowing through. If you see a fully flowing river in a desert, the implication is that the river is not starting from a desert. Because we know desert conditions are dry, there is no precipitation, and there is a high rate of evaporation. But you see a fully flowing river through a desert, it means that river is starting from somewhere else. So it's an exotic river. It is not conforming to the climatic conditions of the region over which it is flowing. It means where it is starting, there is sufficient water supply. It's originating from a humid region, which constantly feeds in discharge, and it sustains through the dry area. So Orange River also resembles the same. It goes through some arid areas and is always fully flowing, which shows that it's an exotic river. That's the explanation that you give to the fact of Orange River. Right. Why will there be intervisibility between spot height 844 in block A5 and 824 in block A5? In block A5, they're talking about intervisibility between the 2 points. Unfortunately, they're not very clear, but we're just going to use the idea of intervisibility. When we talk of intervisibility, we are saying you are able to see one point from another. Are you able to see the other point from another point? For you to be able to see, remember our sight is only straight. We cannot have a curved visionary line. Our visionary line is always straight. So it means if you draw a straight line and there is nothing obstructing the view from one point to another, it means there is intervisibility. But if there is a high-lying feature, it means that high-lying feature automatically is going to block the visibility of the other feature, because we cannot curve our sight around the blocking feature. We can only be able to see in a straight vision. So it means if there is intervisibility between those 2 points, automatically the implication there is no obstructing feature. There's no obstruction. between the 2 points. That's the implication. If there's no obstruction or obstructing feature between the 2 points, then it means there's intervisibility. How does katabatic wind form on the southeast facing slope of the ridge F? Katabatic winds, I will explain how katabatic winds form. Let's assume this is our valley slope. During the night, this valley side here is affected by long wave radiation. There's loss of heat. But the valley floor is not affected. So this loss of heat results in a low pressure forming. Because there's excessive loss of heat due to long wave radiation at night, the air which accumulates here becomes excessively cold and it becomes denser. It sinks because of gravity. It sinks into the valley floor. That is how we experience katabatic winds. One is because of excessive loss of heat from the valley sides at night due to terrestrial radiation. And as a result of long wave radiation, the air immediately above that particular surface is going to get excessively cold. It becomes heavier and it goes down the slope because of gravity and forms a katabatic wind, which ultimately brings very cold conditions in the valley floor. Right. Refer to rural settlement G in block B4. Settlement G in block B4, somewhere here, around this area. What kind of a settlement is that? If you were to look at that, we'll see that there is dispersion of settlements there. State one social disadvantage of dispersed settlements. What are the disadvantages of staying in isolation? If you are not close to your neighbor, you are by yourself. It gives lack of social interaction. You cannot effectively interact with your neighbors because you are far away from each other, or you are unable to share resources. It's a disadvantage. And also vulnerability to crime. You are by yourself and your family. If you are attacked, no one can easily assist you. So it's a disadvantage. Right along those lines, anything to do with someone who is in isolation. Right, we take it to the next question, question number 4.2.7. It talks about the Agrabis faults. It says upstream or downstream erosion is evident. On a falls there's evidence of upstream erosion. It's upstream. A waterfall erodes upwards, up the stream. It migrates upstream. How can erosion impact on the shape of the gorge at Agrabis Falls? The gorge becomes deeper. It deepens the gorge. As there's vertical erosion, the gorge also becomes deeper. That is one aspect. And also the gorge is lengthened because of upward retreat of the waterfall. The waterfall keeps on eroding up the stream. So it means also the gorge will be lengthened. As the waterfall retreats upwards, the gorge also elongates. And also in the case of lateral erosion, we'll make the gorge wider. Makes the gorge wider. Yeah, along those lines. That is how you present the idea. Then question number C says, what is the economic significance of agri-bees falls to the local community? Those falls, how do they help the local community? Automatically, there's going to be tourism, which is going to happen. And with tourism, we're going to have job creation. And with job creation, we are going to have, through the multiplier effect, we're going to have the development of other services, which are likely to support the tourism activities there. Tourism-related businesses are going to be established. You can talk of e.g. hotel and catering or transport. Those businesses are going to be stimulated because of tourism activities. So the community is going to be impacted positively. They're going to get jobs in tourism directly or in hotel and transportation businesses. And that automatically will benefit the society. That takes us to GIS, the last part of our MEMO question. Right, refer to the sketch below to answer questions 431 to 433. What is remote sensing? Remote sensing, basically, in common geographical understanding, is the collection of information or the gathering of information. Gathering information about the Earth from a distance. From a distance. You are not in contact with the actual ground where you need to get the information from, but you are using some form of technology to acquire the information. E.g., if you're using a drone flies over an area and captures information, or satellite images. They are there in space, but they can give us information about different geographical locations. It's a part of remote sensing. So basically, that is as a remote sensing. You got the information from a distance. Then it says satellites and drones capture data in what format? Is it raster or vector? They give us images, which are presented in pixels, so it's raster format. Name 2 advantages of using a drone instead of satellite to map rock formations over agri-bees. Right, if we use a drone, it is more advantageous compared to satellite images. One, it has high resolution. The images taken by the drone will be more visible compared to satellite images. And also, it's slightly cheaper. And also, if you look at the effect of clouds, it's minimal. If you look at satellite images, sometimes they're affected by the clouds. They give us cloudy images which are not visible. So with satellite images, with the drone, it can effectively focus on the area directly without any obstruction or cloud cover. So it's less affected by clouds or some obstructions. So it gives us an advantage. Right. Provide evidence that buffering is taking place in block B2. Buffering, remember, is putting a boundary along a geographical feature. We have our river there, and we want to give evidence that in block B2, there's evidence of buffering taking place. If we look at what is happening along the river there, we can see that there are rows of trees that we can see. These rows of trees, they are evidence of buffering of the river. And also, if you check to this side here, though it's not clear, there's a protected area. And also, if you check any influence of human activities, there are no human influences close to the river here. So the piece of evidence that we can use to justify that there is a form of demarcation taking place, we can look at a row of trees. one as piece of evidence. We can also look at the protected area to limit development, and also we can look at limited human activities. Which means they are restricted. Right, then the last question, why is buffering important along the Orange River? Why is buffering important along the Orange River in that block? Is important for the reason of protecting water quality. For us to maintain the quality of the water, we must limit human activities into the river. It reduces pollution. If we put a demarcation or a boundary, it means that we are reducing pollution into the river. And also it reduces sediment runoff. For example, the role of trees, they help in blocking some of the sediments that are supposed to be deposited into the river. And also it's important for erosion control. And also for the sake of management of floods. Management of floods, we can manage floods through buffering. If we limit human activities or settlement close to the river, it means the dangers of people being affected by floods will be limited because they will be settled further away from the river. And also we can look at safeguarding river ecosystem. And also we can look at other things like stabilizing the river banks. Right. Those are some of the things that we can talk about as the importance of buffering for a particular river, like the Orange River. We try to demarcate, or we try to put a boundary along the river so that we attain water quality, we reduce pollution into the river, we also reduce sediment runoff that is likely to be deposited into the river, we control erosion, we manage floods, we safeguard the ecosystem of the river, and all those are benefits. Right, that is basically the end of our paper. It has taken us to the end of our paper for a total of 150 marks. So that's the picture of a typical paper that you can expect in your June examination. So it takes an effort to prepare, since you're now seeing that the coverage is more wider compared to term one. Term one, we're focusing mainly on one or two topics, but not even full two topics. But now in the June examinations, you are covering a scope of 3 full topics plus map work. So which means you must also be able to cover and prepare yourself enough for the full paper of 150 marks. Right, that takes us to the end of this discussion. I hope it is going to help you to prepare for your examinations, and also it is going to give you an insight as to how you can respond to some different types of questions. And also, I hope we are going to meet in some other discussions closely related, and we are going to assist each other in any of the aspects that need clarification in the field of geography. Till we meet in other discussions, your host in geography. Thank you for watching.
Welcome to ThunderEDUC, an online learning platform powered by professional, highly skilled and qualified educators.
We deliver structured CAPS online lessons for high school subjects including mathematics, physical sciences, life sciences, geography, business studies, history, accounting, English, Afrikaans, and others.
For the intermediate and senior phases, we offer expert teaching in natural sciences, mathematics, social sciences, English, and EMS, designed to build strong academic foundations.
Access the distinction material books by clicking join button on our YouTube channel or download ThunderEDUC app on Google Play Store for all our study material and past exam papers.
ThunderEDUC offers extra classes for rewrites, old curriculum, and other students from grade 4 to grade 12 through online and physical classes.
Subscribe to our YouTube channel ThunderEDUC for reliable curriculum-focused learning and stay updated with the latest educational content.
Please like, share, and turn on notifications so you never miss a lesson.
Visit us at www.thundereduc.com
or call 0786 636 613 or 084 833 1738 for more details.
ThunderEDUC, we focus on quality.